Hello, can you hear me? Okay. So you enjoy the conference till now? You do this? Okay. Hopefully you still do this after this talk. So hi, my name is David.
And I'm Thomas, and we are both software professionals from Vienna. And today we would like to talk to you about the problem of UI state management in applications. And in particular, we want to go into Flux and MVC and how they are related.
So, besides being passionate software developers, Thomas and I have one more thing in common. We really like React. So, who of you knows React? Okay, quite a few people. And who of you uses it in his daily work or in his side project? Okay, 3 people. That's not bad, but there's potential for us. So, Thomas and I, we talk a lot about technology, so we do this most of the time when we're not working. We talk about our work, so it's kind of a bad habit, but it is like it is. And when we talked about React, and we as mentioned, we like React and we like the way how to build web applications with React, we realized, well, React is only a small part of what we really like in building web applications in this whole stack. And we really like the way how React normally, or the way how you could manage your application state with React. So is everyone familiar with application state or state management itself, UI state management? Okay, now let's explain it very short. So UI state management at its core is very simple. So we took this definition from Martin Fowler, of course. Who else? So he says that applications have different kind of state. Yes, you have this record state, you have session state, you have screen state. So their lifetime is different, but essentially you have different kind of state in your application. And the real purpose of state management is to ensure consistency between the states. So to keep the state in sync. And with React, you normally achieve this goal of keeping the state in sync with something called Redux.
And so, yeah, we said we like React, but what we really love is Redux and how it works. And so the question is, what is Redux? Well, it's an independent library, independent from React, and it describes itself as a predictable state container for JavaScript apps. And as I said, it's independent from React. You can also use it with Angular, for example. Doesn't matter if 2, 4, 5, or I don't know what version comes next. But you can also use it. You can also use it in an application that doesn't have a graphical user interface at all, like a CLI, for example. So it's just a library for managing application state. So when you take Redux and you combine it with React, you come up with something that Facebook calls the Flux architecture pattern.
Yeah. So it's Flux. So as Thomas mentioned, Flux was introduced first by Facebook. Who knows Flux? Okay, cool. So Flux is an application architecture utilizing a uni-directional data flow. So that's the definition of Facebook. So let's explain this very simple. So let's take a simple example. So let's think of a web application. So you have some kind of React application. And some users clicking on a button. So some user decides to do some user interaction. This user interaction then gets normally mapped to an action. Okay, so some kind of domain action. The user finishes some ordering process. So the click button gets transformed to user finishes some order. And then there's the dispatcher, which hands over this action to the store. And the store holds the state of the application. And whenever a new action comes to the store decides how to change its state. So probably in this case, he would set a Boolean to finished order or whatever. And every time the state in the store changes, all views which depend on the state automatically getting re-rendered. So every time you change something in your state, all the UIs which depend on the state automatically getting re-rendered. And what we can see here is that only this re-rendering part is actually performed by React. All the rest is implemented by Redux.
So if you're not familiar with Redux, these are some terms that are kind of weird because you never heard of action creators or anything. So in our opinion, a very important question to ask always when you're faced with new technology is why create something new? What's the benefit of creating something new? What does it do better than existing technologies? And so what about existing patterns like MVC or MVP? Why weren't they suitable for managing application state at Facebook? And there's an interesting answer to this question. There is an InfoQ article. I recommend it to everyone read it. And in this article, they explain that they did try to use MVC for their application, but it didn't work out for them. They had problems with inconsistently displayed UI state. So for everyone who uses Facebook, you all probably ran into this bug where you were chatting with someone in the chat window, and you would like read the message, but the indicator at the top says, hey, you have a new message. And when you click on it, oh, there is no new message. So it's this kind of inconsistently displayed data that they had troubles with. And another statement that they have in this article is that they say MVC didn't scale for them. And when we were discussing this, we thought, okay, this is a pretty controversial statement because from our experience, MVC did scale pretty well. And so, yeah, we did what every professional software engineer would do. We Googled it, what is actually MVC and why would it not scale? And the results were pretty interesting, actually.
Yeah, I mean, the results are amazing. So you find the best UML on Google, and we just want to present you some of the search results. So the first one we got is here. So, of course, you have a controller, you have a view, you have a model, and you have this errors. So everybody is speaking to everyone. So this is interesting, but makes not that much sense for us.
So the next result was a bit better. At least the errors are no longer bidirectional, but the view and model kind of keep updating themselves all the time, and we're not quite sure where input from the controller is coming. And yeah, I don't know.
Yeah, I mean, it's very sophisticated. So skip all these errors, do gears instead. It's much better. So yeah, I mean, it brings it to a point. No, it doesn't.
This one's also quite interesting because apparently our whole database is now the model. And also take a look, we have gears again. It's very important to have gears. But yeah, all of these diagrams or pictures didn't really make sense. So we did some better research. And of course, again, Martin Fowler comes up. And he has this very interesting article in which he says different people reading about MVC in different places take different ideas from it and describe these as MVC. And this pretty much brought it to the point, the whole confusion about, okay, what is MVC actually? Why is there so much, why are people thinking so differently about what MVC actually is?
Well, and who of you has seen the talk from Adam Thornhill yesterday? Great talk. I've seen him. Okay.
The keynote.
Yeah, keynote. So, did you realize the MVC pattern he introduced? Well, it was this one. And this is also very interesting. So, probably it's very clever to leave all errors away because this confirms what Martin Fowler says. Yeah, it's not sure. It depends on the context how you really see MVC.
So now if you do some more serious research about MVC, you sooner or later end up with this guy whose name nobody can pronounce because he's from Norwegian, I think.
Reinskog.
Trygve Reinskog, something like that. And so he's the inventor of MVC. He first described this pattern of MVC back in the old Smalltalk days. Who was alive back then? Okay, yeah, very young conference. Sorry. So in this paper, Trygve describes this idea of what he wants to achieve with MVC and what it actually is. And so for models for him, there's a very short sentence that describes this pretty good. He says, models represent knowledge. Models describe a concept of the real world, like a to-do item, something that is, it's an abstract term. And so the models are completely ignorant of how they are represented and how they are interacted with. And next to the models, there's the view. And the view's only job is to create a representation. And this is, in our opinion, a very common misunderstanding. The view is not the representation of the model. The view is a class that creates a representation. And so this means data flows from the model to the view. But the model doesn't know that the view even exists. So the association goes into the other direction. And the third element is the controller, obviously. And the controller's job, described in the terms that Dragway uses, was the controller is the link between the user and the system. So it's the controller's job to map things from the user to abstract events or commands to this model that doesn't know that it's even presented somewhere. And a very interesting finding, in my opinion, is this boundary here that tells us that we're operating on different abstraction levels in our software. So the model is on a different abstraction level than the view and the controller, because these two deal with technical details of the presenting stuff, while the model doesn't know about that.
Yeah. So let's apply all this to the good old web. So finally, some source code on our presentation. Do you like it?
David, this is the Java conference. This is way too concise.
The Java conference. So write some real Java code here. So, no, getting serious again. So let's apply all this to the web. And what's really interesting, the pattern Reenskog described can be applied very simple to the web. So let's take a look at it again. And all that really changes is, okay, the controller takes an HTTP request with some user action normally, transforms this to some model change actioner, and the view re-renders the new state in the model and returns us with an HTTP response. So we can see two things here. The first one is everything is on the server. So the whole MVC pattern is implemented on the server. And the second thing, which is very interesting, there's no JavaScript, and we all know this has changed.
So let's take a look at how things evolved with the introduction of JavaScript. In order to explain that, I want to quickly walk you through this nice little to-do application that has completely irrelevant items. And so you can mark them as done, but you can't undo them, so make sure you actually do them before you click on the button. And if we don't have JavaScript, this means only the view can create us a new representation. So if we click on the button, we issue an HTTP request, and we get back a new view. Now this user experience sucks, because it's like the whole view refreshes and the whole UI refreshes, and despite that, we only want to make this little item green. So we introduce JavaScript, and if we do this, we make an asynchronous HTTP request, of course, and we get back some JSON, and then we just modify the HTML on the client.
So now we could get back some JSON.
We could get back some JSON, but we know how things evolved, and today we are only doing JSON and then call it REST. So what happens now is that we introduce duplication, because this class here that says how does an item look that's done in the CSS, we duplicated that because our JavaScript needs to know what this class is and our view knows. And yes, I'm aware this is a very simplified example and you can probably get around that, but it should demonstrate that the more functionality that you put into your JavaScript, the more duplication you're causing in the view and in the JavaScript. So the question is, how do we tackle this problem of duplication?
I don't know. Anybody knows how to tackle duplication? Okay. Well, actually, I know only one real way to tackle duplication, and this one is very simple. Yeah, delete it or get rid of it. So that's the only way I know. And basically, that's exactly what happened in the MVP or in the JavaScript. So people started to implement MVC with JavaScript. So that where we went to. So people started doing all this stuff which was currently done on the server, on the client with JavaScript. So they did it with MVC, for example. They did it with MVP. They did it with MVVM. They did it with MV whatever, yeah, how they call it at Angular. But basically, that's what they have done. They did all this what was done on the server, on the client now. And, well, there are lots of implementations of MVC in JavaScript. I like this one from Peter Michor. I'm pretty sure you don't know it, or does anyone know this? Yeah, I didn't know it either, but it's really good because what he tries to do is he really tries to implement the design or the pattern Reenskog described for Smalltalk with JavaScript. So this is very, very, very near to the original thoughts from Reenskog. So this is really interesting. And of course, there are lots of others. And in our opinion, another MVC implementation in JavaScript is React plus Redux.
And so now, before you grab your tomatoes, let us explain why we think this way. And it's actually quite straightforward. So in MVC, we have three components. We have a view, and we can try to map these two elements of a React Redux application. And so what is the view's job? The view takes data and creates a representation of it. Yeah, I think I don't have to repeat this anymore.
But can I repeat this anymore? Because it's so important, and it's such a common misunderstanding in MVC applications or in MVC frameworks that the view is actually the HTML, and this is not correct. In my opinion, it's not correct, because the view is the component which renders the HTML. Okay? So the view maybe uses some HTML template and renders a HTML out of it, but the view itself is not the HTML. Just to make this clear once more.
Yeah, thank you, David. So welcome. What can we map this to? Yeah, we can map it to React. This is what React is doing. It takes data and it creates a representation out of it. And why is this true? Because it's also on Wikipedia. Wikipedia says that React is the view part of MVC, and Wikipedia never lies. We all know this.
So go home and read the rest on Wikipedia of what we're saying. Because
okay,
Wikipedia never lies.
Second part, model. What's the model's job? Models represent knowledge. It means that models implement your business logic. Models implement all the business rules that you have, and they encapsulate state. So how is this handled in Redux? Well, it's the Redux store. The Redux store encapsulates your data. It takes actions and it transforms the state based on these actions. So these two can, literally be mapped to one.
Yeah, things getting a little bit strange with the controller.
Because we're already done with this, right? So where's the controller?
Yeah, the controller is a little bit of a strange guy. But let's reconsider what was actually the purpose of the controller in MVC. As Thomas mentioned before, the controller takes some user action and transforms it to some model transformation action. So it takes a user action, transforms it, the model changes. And when we think back to the Flux architecture I showed before, so there was this UI, this React UI. So the user has some user interaction. This interaction gets mapped to an action. This action, or this dispatcher hands this action over to the store, and the store finally gets updated. So I think you get it, that the main idea, the main goal behind this is pretty much the same. There's just some other wording and some more components, but the controller basically is some array of components in Redux, I would say.
Yeah, more or less.
Still on. So as we can see, the structure is very similar. So we've proven this here, or we tried to prove this here, that the structure of MVC and Redux plus React is quite similar. So, but the structure isn't all. So we know frameworks deliver more than just structure. They have some kind of goals. So let's take a look at the goals of Flux. So we took a look at the documentation on GitHub, on things people from Facebook said. What are the main goals of Flux? What are the main goals of the Flux architecture? What purpose has React and Redux together? What problems does it solve? And we found four very important selling points or main criteria they always speak of. And the first one is unidirectionality. Does anybody know unidirectionality in UI state management? It's familiar to unidirectionality. Okay, so basically the idea is very simple. If I take a look at Flux again. So we have this React UI. This triggers some kind of action. This dispatcher hands this action over to the store. The state in the store changes. Boom, React view gets re-rendered. And what we can see here is we have this always in this circle of direction. And according to Redux and according to the Flux team, this makes application very easy to understand and also easy to test, because you don't have anything from the rack to the store. You always have this circular direction. How does this work in MVC, Thomas?
Yeah, actually exactly the same. So we have a controller, a model, and a view, and we always go in this circle. So we never update the model from the view. We always go from the controller. Yeah, that's basically it. It's exactly the same, actually. The thing is, there are other approaches to this. So not every UI state management framework is unidirectional. If you think of MVVM, for example, that's implemented by Angular, you have binding, and binding is always bidirectional. And then you don't have this nice circle of, okay, I always know where my data comes from, because you're not quite sure which of the two parties updated the state.
Okay. So another selling point Flux always argues with is predictability. So, well, this one is also quite obvious. So you have some state in your store, you have some action, you again have some state in your store. So if you have some state in your store and you apply the same action again, you will get another state. And you can do this again and again and again, and it's quite predictable. So you know how actions will change the state in your store, and you could describe this with a very simple function. So the store state plus an action is a new store state. But this one is always predictable. If you know the store state and the action, you know the new store state.
Yeah, this is also the reason why it's usually implemented in the form of pure functions. And the thing is, if we just take this to the object-oriented world, it's like the same thing in MVC. We have a model that has some initial state. We apply an action, which is probably a method call, or we send it a message, and we get a new model state. And this can be tested in exactly the same way as the Redux variant.
Yeah. So the third point, single source of truth. So the single source of truth in Redux is quite simple. Also, we can see it here, the store. So the store in our Flux architecture is the only way where we store our state. So there's no second store. I'm cutting corners here. You could have a second store, but it's on the same position then. So, but all these other things here don't have some kind of state. Of course, you have some very short-living state, but it's not really persistent. So all your state is located in this store. And of course, this is a big advantage, because you know, okay, the only way to update your store, as we have heard before, is to create an action and apply it to the store. And so it's very easy to understand what's currently going on in the application. So you can retest stuff, because you only need the state of the store and apply it to the current running instance of your React application. And this is where single source of truth is really big, because you can do this. In lots of applications, you have state everywhere, sorry. And this is one of the really big advantages, I think, which come with Flux. So
yeah, I think you got me with this one, because we now have 3 models or even more. And it seems like state is now scattered across the application. But if you take a closer look, and might be more easily be seen from like the last rows, all of these models could be seen like, this is my application model, and I could reference them from each other. So more or less you have a single source where you go to for if you want to know about a particular state. And also if you look at it from the context of the information that is stored, whether or not a particular to-do item is done or not is only ever stored in one place. So it's never scattered. You don't have to like combine 3 Boolean values in order to get that information. It's always the single source of truth of information is still valid.
Yeah, so no duplication is the point here. Yeah. Yeah, the next one, consistently display data on the UI. So this is where they got me. So I figured, I didn't know exactly when I became a fan of the Flux architecture, but this is really the thing where I said, wow, I go with Flux because it's crazy. It's that easy, and it makes things so easy. Because for me, the real big advantage of Flux is, as I mentioned before already, so you change something in your state by an action. So that's the only way to change your state in a Flux architecture. And you don't have to do anything, because all the views in your application, all the UI components, know on which state they depend on. And if they recognize, okay, the state I'm depending on changed, okay, then they re-render. So this is not my beer anymore, and they do it on their own. And you can describe this again with, of course, some very easy function. The view takes a store state and renders an UI.
Yes, and with MVC, it's again exactly the same, actually. They even use, so if you look at Smalltalk implementations of MVC, they even use the same pattern. It's the observer pattern in both places. So views subscribe to models, and React views subscribe to the store, and any kind of updates just get propagated to all the subscribers, and they can re-render as soon as the state changes. Of course, there are some optimizations to it. Okay, if the state I depend on doesn't change, I don't re-render, but the idea is the same. You don't have to specifically tell the view, okay, now go update yourself, because it already knows because of the state change that was the actual intended behavior.
So, well, what we basically said, it's all the same. Yeah. So structure is view is React, model is store, controller is some array of React components, and the goals. Both fulfill some kind of the same goals. Maybe Redux and React is some kind of more opinionated to achieve these goals, but basically the goals and the structure is mappable. So what we say is that you can achieve what you can achieve with MVC can also be achieved with Flux. So does anyone remember the title of this talk? Come on. We saw that. Okay, so one guy, what was it? Right. Flux, a modern way of doing MVC, question mark.
It probably should have been just Flux, another way of doing MVC, because this is what it all comes down to, and we hope we were able to convince you that the differences between those frameworks or approaches are so marginal that, in our opinion, this is just another way to do MVC, because both want to achieve exactly the same things. They just use different terms and structure everything a little bit differently. And as we've seen, almost exactly the same.
So why is this important for you? And now it's really getting interesting for you, I think. So wake up and listen 2 minutes. Why is this so important, this message? Because, I mean, don't get me wrong, and I think I can also speak for Thomas, we both like React, we both like Redux, we implemented a couple of applications with the stack, and probably we would do it again.
There will be some more.
There will be some more, and we would do it again. But the problem really is, when you start talking with some React developers normally, or some JavaScript experts, or some other guys who use Flux a lot, they normally say, come on, use Flux in your application, you got all these big advantages. Yeah, and then you ask, what advantages? Yeah? And then normally they tell you one of the 4 points, one of these 4 key goals we showed you before. And then they say, come on, use it. Come on to this React land and use React, and probably buy some training from me, and we will train you how to use React really. And this is interesting because, as we have seen, Reenskog did this 40 years ago. So 40 years. Reenskog had some pattern in his head or in his mind, or described some pattern which basically fulfills the same goals and same structure like Flux does now with other wording. So if you really should take one message from this talk, it's probably that you shouldn't do this hype-driven development. You shouldn't follow these new buzzwords. So you should not learn frameworks at all, I would say, because this doesn't scale. You can't learn each new JavaScript framework, but what you should do, of course you should learn, but you should probably learn the concepts behind these frameworks. Because when you understand the concepts behind this framework, this is some real big value for you as a developer, because you can reuse them, as we have seen, from Smalltalk till now to JavaScript. So, as mentioned, learn concepts, not buzzwords. So, thanks.
Yep. Thanks for listening. Just a quick few words about ourselves. So, as I already introduced myself, I'm Thomas. And yeah, feel free to approach me and talk to me. However, if you want to do this, do it in the next 3 weeks, because I'm going to meet this guy again, going to Sydney in April. But yeah, but follow me on Twitter, ask me any kind of questions, whatever you like.
Yeah, I'm David. I'm working as a freelancer in Vienna, mostly on Java and JavaScript. So sometimes .NET when I run out of money. No, just kidding. .NET has some really interesting ideas and concepts, I think, beside the new frameworks. Yeah, that's it for me.
Yeah, and we also do like to make software in our free time, and so we have this little project, and we just advertise it here a bit. It's called Not.io, and whenever you run into the situation of being around with a few of your friends and everyone has a bill, someone pays the coffee, someone pays the beer, someone the fuel costs, and you don't know, okay, how to split this up, give it a try. It's open source on GitHub, and tell us what you think, or even contribute, fix a bug, whatever you like. Yeah, thanks for having us.
Thanks.